guys, today we are going to see about atomic structure. Before that we have to know about what is mean by atom. Atom is a very smallest particle. Very smallest particle. And we cannot divide that particle. So it is indivisible particle. So what is mean by atom? Atom is a very smallest particle which is the major source of a substance, and we cannot divide that particle, so it is known as indivisible particle. And also it contains some subatomic particles. What are the subatomic particles? Means proton, electron and neutron. What is mean by proton? For example, this is an atom. This is an atom, okay. In this atom, inside proton will present and neutron will present. And outside electron will present. Okay. So this proton is positively charged particle. Proton is positively charged particle, and this electron is, which is opposite to proton, negative charge particle, and neutron have no charge. Neutron have no charge. Here the proton is positively charged particle, the neutron is not having any charge, and electron is negatively charged particle. What are the symbols for proton, electron and neutron? For proton, the symbol is H. For electron, E. For neutron, N. What is the charge I said? These are all the symbols for proton. These are all the symbols. Symbols for subatomic particles. For these particles, these are all the symbols. For proton, H is the symbol. For electron, E is the symbol. And neutron, N is the symbol. What is the charge I said here? Proton is positively charged. So, H plus. Positive charge means we have to write what symbol here? Plus. Electron, what charge I said? Negative charge. So, negative charge means what symbol you have to write here? Minus symbol. Neutron, what charge I said? It is not having any charge. So, you have to write 0. Okay. So, depending upon these symbols, you know, proton is positively charged, electron is negatively charged, and neutron is not having any charge. Okay. Who invented proton, electron and neutron? Who invented proton? Goldstein. Goldstein invented proton. Like that, who invented electron? J.J. Thomson. And neutron? Chadwick invented neutron. These are all the inventors who invented proton. Goldstein invented proton, and J.J. Thomson discovered electron, and Chadwick discovered neutron. Okay, and come to this diagram. What I said here, inside proton is present and neutron is present. So this is fully positively charged. Why? Because neutron have no charge. So it is having 0 charge. Proton is having plus charge. So this is fully positive. This is fully positive, and this is known as nucleus. The center part of the atom is known as nucleus. This is the atom structure. The center part I said no, which is containing proton and neutron. Neutron have no charge, proton is having positive charge. So this is fully positively charged, and this is known as nucleus, and this is a heavy dense part of this atom. So the electron is revolving around the nucleus. Electron is revolving around the nucleus. So it is circulating like this. Electron is revolve around the nucleus. Okay. What is mean by orbit? A circular path in which the electron is revolving around the nucleus is known as orbit. Orbit means what I said? A circular path which the electron revolves around the nucleus. Here, the electron is revolving around the nucleus, no? So that is known as orbit. The next one is what is meant by orbital. What does mean by orbital? A three-dimensional space where the probability of finding an electron is maximum, a three-dimensional space where the probability of finding an electron is maximum, and that is known as orbital. There are 4 orbitals totally. What are the orbitals? Orbitals type are 4 totally. S orbital, P orbital, D orbital and F orbital. Okay. There are totally 4 orbitals are there. S, P, D and F. Okay. What is the shape for S? S is the spherical shape orbital. So only it is denoted as S orbital. P is a dumbbell shape. Dumbbell shape orbital. So orbital is, orbit means what I said. Orbit means a circular path where the electron is revolved around the nucleus, and orbitals means what I said. A three-dimensional space where the probability of finding an electron is maximum, and the orbitals are divided into 4 types: S orbital, P orbital, D orbital, F orbital. What is the shape I said? S orbital spherical shape, P orbital dumbbell shape. I said 4 types S, P, D, F, and this P orbital have 3 orientations. It also divided into 3: Px, Py and Pz. Okay. This Px orbital will have the axis in x-axis. Okay. Like this it will have in y-axis and it will have a z-axis. Now I will draw the diagram. You know. Px orbital. The shape of the Px orbital is, this is x-axis and this is y and this is z. X, y, z. The Px orbital present here. So here this line won't come. I'm just drawing, but the line won't come. So the actual diagram of the Px orbital is y-axis, z-axis, and in between the x-axis the Px orbital will present. So this is the complete diagram for Px orbital. Now Py orbital means in which axis it will present. In y-axis the Py orbital will present. Which is y-axis? The upper side. Y-axis. So as usual x-axis and z-axis will be there. So this is the shape for Py orbital. Now Pz orbital, x-axis, y-axis, and in the z-axis it will present. So this is the diagram for Pz orbital. Now come for quantum numbers. What is mean by quantum numbers? I already told what is mean by orbit. What I said about orbit? The electron revolved around the nucleus. A circular path where the electron revolves around the nucleus, and that is known as orbit, I said. Here quantum numbers are used to denote the position of an electron, where the electron is present. The electron is revolving around the nucleus. No, here nucleus is present, and as usual the electron is revolve around nucleus. Where is the position of the electron? Okay, the quantum numbers are used to designate the position of the electron, and this quantum numbers is divided into 4 types. Principal quantum number. Second one is azimuthal or subsidiary quantum number. It has 2 names, azimuthal or subsidiary quantum number, and third one is magnetic quantum number, and fourth one is spin quantum number. So what I said, quantum numbers, why we are using this quantum numbers? To designate the position of the electron, and it is divided into 4 types: principal quantum number, azimuthal or subsidiary quantum number, magnetic quantum number, and spin quantum number. What are the symbols for principal quantum number? Means N is the symbol for principal. Azimuthal or subsidiary, what is the symbol? L is the symbol. For magnetic, M is the symbol. For spin, S is the symbol. Okay, now I explain what does mean by principal quantum number. Why we are using principal quantum number? To designate the distance between electron and nucleus. What is the distance between electron and nucleus? So, the principal quantum number is used to designate the distance between the electron and the nucleus. Okay. And next one, what I said, azimuthal or subsidiary quantum number, which is denoted as L. It is used to designate how many subshells are present in the main energy level. Subshells. How many subshells are present in the main energy level. And third one is magnetic quantum number is used to how many orientations are possible. How many orientations are possible. So for that it is using. And the spin quantum number means electron spin. This electron is revolving around the nucleus, no, whether it is a clockwise direction or anti-clockwise direction. Clockwise direction or anti-clockwise direction. So that is known as spin quantum number. The electron revolving in the clockwise direction or anti-clockwise direction. So this is the explanation for these 4 quantum numbers. Now what is the formula? How we can calculate this azimuthal or subsidiary quantum number means L. What is the symbol? I said azimuthal or subsidiary. Here I said no. L. L is equal to n minus 1 is the formula. And M is equal to, for magnetic I said M no. M is equal to 2L plus 1 is the formula. For spin quantum number, the plus of value will come or minus of value will come. Why plus of or minus of? Whether it is clockwise or anti-clockwise, we don't know. So it depends on the orientation. So the formula for azimuthal or subsidiary quantum number L is equal to n minus 1 and magnetic quantum number M is equal to 2L plus 1. For spin, this value will come. I said no. What are the formulas for principal quantum number? Symbol I said N and azimuthal L I said and magnetic M I said and spin S I said. L formula is N minus 1, M formula is 2L plus 1 and S formula it will maybe plus of or minus of I said. Now there are totally 4 shells are present. I said no, subshells K, L, M and 4 shells are totally present. In each shell, how many electron will present? How can we calculate how many electron will present? According to the formula 2n squared, we can calculate how many electrons are present in the k element shell. For example, here principal quantum number symbol is n. Okay, so I will put the tabular column for this. N. Here n values are 1, 2, 3 and 4 we will write. And another one. How many subshell I said? K element subshells. K, L, M and N. And here we are going to calculate how many electrons are present in each shells. K shall have how many electrons? L shall have how many electrons? Like that we are going to calculate. For that we are using the formula. What formula I said? 2n squared formula we are using here. Okay. So here 2. Here n value what we are going to write? 1. So 2 into 1 the whole square which is equal to 2 into 1 which is equal to 2. Like that here this 2 will come automatically here. N value what we are going to write? 2 square which is equal to 2 into 2 squared. 2 to so 4. 2 4 so 8. So totally 8 electrons will present here. Like that here in this formula now we are going to write instead of this n value what we are going to write? 3 squared which is equal to 2 into 3 3s are 9 and 9 2s are 18. Now finally instead of this n what we are going to write? N value 4 we are going to write 4 squared which is equal to 2 into 4 squared. 4 4s are 16. 16 into 2 32. So finally these are all the values for the k element shells. By using which formula we are calculating? 2n squared formula. N value we are writing 1, 2, 3, 4. The shell k element shell. How many electron will present? N. If we put n the value 1 means we will get 2 electrons. These are all the electron values. 2 electrons. If we put 2 for n, we will get 8 electrons. If we put 3 for n, we will get 18. For 4, we will get 32. Now like this, some sums we will do. Okay. Some sums are given. The first sum is for subshells 3s, 3p, 3d. What are the values of the principal and azimuthal quantum numbers? Here, kindly listen the question. Subshells, they already given 3s, 3p, 3d. So the subshells, they already given 3s, 3p, 3d, and they are asking what? What are the values of the principal and azimuthal quantum numbers? What is the symbol I said? Principal n, azimuthal L. So the given subshell value 3s, 3p, 3d, we have to find out the n and L value. So I put a tabular column. So what they given? Subshell they given. We want to find n and L value. Subshell name, what are they? 3s, 3p, 3d. So right here 3s, 3p, 3d. Okay, n value you can find out easily without any formula. Before this s orbital, before this p orbital, before this d orbital, what number is present, and that is known as n value, and that is known as n value. Before this orbital, what number is present, that is known as n value. So without any formula, you can write here 3 is present, so 3, here also 3, here also 3, here also 3, here also 3. So you can easily find out n value. But for L value, you have to use one formula. L is equal to n minus 1. For example, here 3 present, I written here 3. For example, here 4d will present means what is the n value? 4 is the n value. For example, 5p will present means what is the n value? 5 is the n value. Okay, these are all the examples, but here 3s, 3p, 3d was given. So we written here 3, 3, 3. Now L value we have to find by using the formula L is equal to n minus 1. Can you remember? I already told 2n squared formula means how we written. Instead of this n, first we will put 1. Then we find out some answer for k elemental. Then instead of this n, we return 2. Then we find out how many electrons will present in the k elemental. Like that, here this n, you will write 1. Here for that n, you will write 1, 2, 3, 4. Like that, we will use the L values. Okay. L is equal to n minus 1 is the formula. First, we will write n is equal to 1 in this formula. L is equal to n minus 1. This is the formula. Here we are writing, instead of this n, we are going to write 1. So L is equal to 1 minus 1. So L is equal to 0. If we write n value 1 means we will get L value 0. So you have to write here 0. Now we are going to write n value 2. Okay, what is L formula? L is equal to n minus 1. Equal to what value we are going to write? 2. 2 minus 1. 1. So L value is 1. If we write n value 2 means L value we will get 1. Now third one, n is equal to 3 we are going to write. L is equal to n minus 1 formula equal to 3 minus 1, we will get 2. So we will write n value 3 means L value we will get 2. So like this, using this formula, we are writing n value 1, 2, 3. We are getting L value 0, 1, 2. This is the answer for this question. Like that, I will give you one homework. If you understand that sum means, you can easily find out the answer for this question also. Here they are given 4s, 4p, 4d, 4f subshells. So we are writing subshell tabular column. What are the values of n and L? Principal and azimuthal quantum number values we have to find out. So the subshell value they given 4s, 4p, 4d, 4f. For here you have to write 4s, 4p, 4d, 4f. Find out the answer of n value and L value. For L value, use this formula. L is equal to n minus 1. And find out the answer. Write the answer in the comment section. Thank you so much.